guys from Microsoft. My name is Tomás Scherrer.
I'm Diego Pinto.
And we are research students here at the Wireless Technology Research Center. And on our free time, we design digital synthesizers. When we design a new synthesizer, there's a big problem we always face. How will the user configure it? Because synthesizers are meant to generate completely new sounds. And so the user has to deal with a lot of parameters until he gets the sound he wants.
When we first heard about Dare to Dream Different contest and the .NET Micro Framework features, we started dreaming about a synthesizer with an unique user interface. Plus, we wanted it to be really easy to play and to integrate it in a band.
So we have designed a synthesizer that can be entirely played and configured on a touchscreen with wireless connection to other electronic instruments. Here it is, the MicroSynth. Now let's get down to the nuts and bolts and see how it works. In order to use the most of .NET Micro Framework features, we had to develop a synthesizer with a lot of parameters to change. So when this board first arrived, we were amazed by the user interface capabilities of it. But we soon realized that it wasn't fit for high-speed, real-time, CPU-demanding applications. So we have chosen this separate FPGA board to do the dirty job, while the Tahoe here only deals with the user, sending his commands to the serial port.
We have designed a phase modulation synthesizer, for it's very flexible, has a lot of parameters to set, and sounds very nice too. We have also chosen it because there is a common belief that this kind of synthesizer is very hard to configure, and that is the reality we dream about changing.
The synthesizer was entirely described in VHDL and runs on this board here. It has 10-note polyphony and 9 operators, plus it is MIDI compatible. The user interface is what the MicroSynth is really all about. From here, you can access every feature of our synth. Let's start with the melody column. In the melody column, you can access the screen where you actually play. Here you can see 6 different scales, and each one of these bars is the notes you will use to play. When you tap on one of these notes, the synthesizer plays the respective note. One thing you have to notice about these bars is when you press it on the top, it is louder than when you press it on the bottom. So this provides the musician additional expression freedom. The class that defines these roles is also based on the user interface element class. In our first test, we concluded that the onMove event provided by the touch namespace was too slow for musical performance. So when the user touches one of these roles, it starts a thread that pulls the touchscreen, which gives us enough speed to musical performance. Plus, this window is the only one that doesn't have an exit button on the touchscreen, because we didn't want the musician to accidentally exit during musical performance. So pressing any push button sends you back to the main screen.
Now, what if we wanted different notes? What if we wanted different scales?
That's what the Play Config window is there for. From this screen, you can select which notes will be displayed on the Play window. These radio style buttons here selects which row we are configuring, and the Include button selects whether the row is going to be displayed or not. For example, right now, I'm including row 3 in the Play window. With these radio buttons here in the middle, the user can select which notes are going to be included in the included row. Right now I have included a C major chord, but let's guess we want more than 6 notes in our row. We can use these 2 sliders here to increase the amount of octaves or individual semitones. Let's guess we want it a little bit higher. We can also use the Scale Presets button to select among a major scale, a minor scale, or a full chromatic scale. Let's guess we wanted C# major as our scale. We select C# as the first selected note in the row and press the major button. And this is how C# sounds. Using this configuration screen, we have full flexibility to select any scale and any chord we might imagine. The timbre column, here in the middle, is where we can select how the synthesizer will sound. These 16 radio buttons here are presets already loaded in the memory. We can also configure each one of these presets. Now, this screen is the heart of our synthesizer. Each one of these operators you are seeing here can be seen as a basic musical building block, composed of an oscillator and an envelope. Using this switch, we send the sound of the operator to the speaker. The envelope is how the sound will evolve to time. We can use these 5 parameters to control this evolution. The peak is the overall volume of the oscillator, and the sustain controls its intensity during the active time of the note. The attack controls how gradually the note starts. This has a sharp attack, and this has a smooth attack. And the release controls how gradually the note ends. This has a sharp release, and this has a smooth release. This kind of envelope configuration is a commonplace in the synthesizer world. Until today, you could only have this kind of graphical preview on computer-based synthesizer. Now, thanks to .NET Micro Framework, we can have it in a standalone synthesizer. Now, the sound of a single operator is not that interesting. So, what phase modulation is really all about is actually modulation. So, we modulate operator 1 with operator 2. We can make very complex modulation connections to achieve very different sounds. Now, what if you want to take your microsynthesizer to your band and start a jam session? How will it communicate to the other instruments? The XB module here is our answer to this question. It can send all the MIDI messages from the screen to the other instruments, or it can receive MIDI messages from other instruments to the microsynthesizer, as we are doing here. All the MIDI routing in the microsynthesizer is made in the band column. Here we have the XB module, here we have the touchscreen, and here we have the synthesizer. With these switches, we can control the flow from one of the elements to the others. Here we are sending MIDI files from a computer to the XB module to our microsynthesizer. Here we are doing the opposite. We are sending MIDI messages from the microsynthesizer to another synthesizer in the computer. What most impressed us on .NET Micro Framework was the ability to quickly write an embedded application, just as we are used to do on the computer. We didn't have to worry about hardware issues, meaning reduced development effort. When we first heard about this contest, we dreamed about a user-friendly synthesizer. And now, thanks to .NET Micro Framework, it's not a dream anymore, it's reality.